Good morning. Today we are going to discuss about abnormal combustion. In normal combustion, in case of SI engine, the flame initiated by the spark travels across the combustion chamber in a fairly uniform manner. Under certain operating conditions, the combustion may deviate from its normal course, leading to the loss of performance and possible damage to the engine. This type of combustion may be termed as an abnormal combustion or knocking combustion. The consequences of this abnormal combustion are loss of power, pre-ignition, and mechanical damage to the engine. In SI engine, the combustion, which is initiated between the electrodes of the spark plug, spread across the combustible mixture. A definite flame front, which separate the fresh mixture from the product of combustion, travel from the spark plug to the other end of the combustion chamber, as shown in this figure number 1. Heat release due to the combustion increases the temperature and consequently the pressure of the burnt part of mixture above those of unburnt mixture. In order to effect pressure equalization, the burnt part or the product of combustion will expand and compress the unburnt mixture adiabatically, thereby increasing its pressure and temperature. The process continues as the flame front advances through the mixture and the temperature and pressure of the unburnt mixture are increased further. If the temperature of unburnt mixture exceeds self-ignition temperature of the fuel and remains at or above this temperature during the period of ignition lag, spontaneous ignition or auto-ignition may occur at various pinpoint locations, as we can see in this figure. This phenomena is known as knocking, and the process of auto-ignition leads toward engine knock. The process of auto-ignition leads towards engine knock. Because of the auto-ignition, another flame front, as you can see in this figure, another flame front starts traveling in the opposite direction to the main flame front. When these two flame fronts collide, a severe pressure pulse is generated. The gas in the chamber is subjected to compression and the rarefaction along the pressure pulse until the equilibrium is restored. This disturbance can force the walls of combustion chamber to vibrate at the same frequency as of the gas, and the gas vibration frequency in automobile engine is of order 5000 cycle per second. In summary, when auto ignition occurs, two different types of vibration may be produced. In one case, a large amount of mixture may auto-ignite, given a very rapid increase in pressure throughout the chamber, and there will be a direct blow to engine structure. Human ears can detect the resulting sound and consequent noise from the vibration of engine parts. In other case, large pressure differences may exist in the combustion chamber, and the resulting vibration can force the walls of chamber to vibrate at the same frequency as of gas, and an audible sound may be evident. The impact of these, the effect of detonation or on engine are noise and roughness. The abnormal combustion produces a loud pulsating noise, and pressure waves. These pressure waves travel back and forth across the cylinder, and the presence of vibratory motion causes the crankshaft vibration and rough running of engine. It can also cause mechanical damage. High pressure waves which are generated can increase the rate of wear of parts of combustion chamber, erosion of piston crown, cylinder head, pitting of inlet and outlet valves, and complete failure of the engine. It may also result in increased carbon deposit. Knocking is accompanied by an increase in the rate of heat transfer to the combustion chamber valve, and also due to increase in the rate of heat transfer, the power output as well as efficiency of the engine decreases. So it should be the aim of the designer to reduce the tendency of knocking in an engine. Thank you. In the next class, we will be discussing about the effect of engine variables on knocking tendency.